mini break to see how the stream is doing. So far so good. Oh, whoops, sorry about that. Should have done this instead. Okay. Everything's looking good. Our audio is good. All right, perfect. I just like to check in every hour just to be able to make sure. Now we can move on safely to question number 11. Hopefully this thing changed. Let me just double check. Okay. So yep, let's move on to question 11. We have, what is the molar mass of cobalt-3 nitrate? Okay. And how many oxygen atoms are there? There's 4.25 grams of cobalt-3 nitrate. So right away, this is really bothering me, and I'm glad my colleague addressed it, because cobalt-3 nitrate should be CONO3, not 2, because nitrate ions, NO3, are just 1 minus. Cobalt-3 is implying that it has a 3 plus. For these to cancel out and balance, you need 3 nitrates. So I'm glad my colleague, as he shows there, is dealing with cobalt-3 nitrates in its true form. So let's go on like that as well. So we want to find out first the molar mass of cobalt-3 nitrate, okay? So we want to add the constituents. So we have 1 cobalt, and now we're going to multiply 3 into each part there. So we have 3 nitrogen, and we have 9 whole oxygen, okay? So now we got to refer to the periodic table to see how much each weighs in their atomic mass units. Cobalt is right here. Element number 27, 58.933. Nitrogen is element number 7, 14.007. And there's 9 whole oxygens, which each weigh 15.999. Okay, so that is 58.933. Whoops, sorry, that's not what I want to do. Because 1 times that, we're going to have the same number. I don't want to add just yet. 58.933. Perfect. And then this is where we want to multiply first. So 14.007 times 3, 42.021. And then the last one we have 15.999 times 9, 143.991. I'm going to add it all together. Plus 58.933. So total we should get for the molar mass is 244.945. And the most important part you cannot forget is the units, which is grams per mole. So this should be the molar mass that we get. Okay? So with that being said, it's also asking how many oxygen atoms are there in 4.525 grams of cobalt-3 nitrate. So now we want to find out how many moles are there in that 4.525 grams, and then we're going to use Avogadro's number to find out how many atoms of oxygen are there. But before we even go there, we need to first find out how many moles of oxygen per 1 mole of cobalt, which should be a 9:1 ratio, as we've done here. Well, to be specific, 1 mole of this molecule. So with that being said, we have 4.525 grams. And we want to convert it to moles. So we're going to have to do this. 244.945 grams per every 1 mole of the cobalt NO3. And now for every 1 mole of cobalt NO3, we have 9 moles of oxygen, because as it shows here, 9 of O. And now this is where we factor in Avogadro's number. For every 1 mole of any element, but in this case is oxygen, we have 6.022 times 10 to the 23rd atoms. So there's going to be a lot of crossing out just to make sure we end up with the right unit, atoms of O. So grams, moles of cobalt NO3, cancel out with that, moles of oxygen with moles of oxygen, and that's all we're left with, atoms of oxygen. So we have 4.525 divided by that molar mass times 9 times 6.022 times 10 to the 23rd. We get, there should be 1.00 times 10 to the 23rd oxygen atoms. Based on what the calculator is saying, hopefully with this we're able to actually cancel the right units. But let's see what our colleague was able to do. So they did get the molar mass was 244.93, which is close to what we got. It just depends on the periodic table you're using. As you can see, their values slightly different from mine. Okay, and then we found the moles. Well, that's what they did, 0.01847. Then they multiplied that by 9 because there's 9 moles of oxygen atoms, and they got this 0.1662. Then they used Avogadro's number, perfect, and they got 1.001, which is actually what I got. I just wanted to round up a little bit earlier, but exactly, they should. I'm just trying to check the original question. I see. So that's why you should round to 1.001, because the original number was 4.525, which had 4 significant digits. So I will just add that. And yep, my calculator is 1.001 as well. So there are indeed 1.001 times 10 to the 23rd oxygen atoms. So this is correct. Now for question number 12, we have